talked a little bit about structural isomers. Now let's do structural isomers with skeletal structures. And let's say we'll talk about this example that we've already worked on. So C5H12, you can draw your first one as a Lewis structure because there's nothing like a Lewis structure to actually confirm that you have the bonds that you think you do. And what I mean by that is if you can count up all the actual hydrogens, and there are 12 of them here, you can confirm that all of these carbon-carbon bonds are single bonds. And then you can draw this as 1, 2, 3, 4, 5. Again, not the angle here being approximately 109, 120, somewhere in there. Something showing the zigzag nature of this bond. Then when you make a isomer, you take one off the end and reconnect it in the middle. That is a different molecule. And then the third one is actually, well, we can draw it in tetrahedral with the center carbon here with 4 carbons around it. So we can draw out and back wedges for this one now. And those are all carbons because there's nothing else showing. And let's go ahead and talk about something called geometric isomers. So geometric isomers are a form of isomers that have the same chemical formula, same bonding pattern, but different spatial arrangement of the atoms. And this one, geometric isomers, at least the way that we're going to look at them in this course, are always going to be have one double bond in them. They get much more complicated, but that should be plenty for us. If we look at a molecule that does have a double bond, and we simply, let me go back here, take and have 2 chlorines, 1 on each carbon, and 2 hydrogens, and then we compare it to another molecule with the same formula, same bonding pattern, meaning that this carbon has a chlorine and a hydrogen, as does the other one, as does both of the carbons in the other isomer, but different spatial arrangement of atoms. These two are different molecules, and they will have different properties, as we will discuss, and we can discuss now. And we don't have to do nomenclature of these. However, it can be helpful to know a little bit about nomenclature. So this one that has both of the chlorines on the same side, such that they sort of look like a letter C, is called cis. So they're on the same side. And this one, where the 2 chlorines are opposite each other, is called trans. And these are what are also called cis-trans isomers. So these are different molecules, and the reason they're different molecules is because the double bond is rigid and the double bond does not rotate. Does not rotate. If it rotated, and this would be true if it was a single bond between these 2 carbons, if it rotated, then these would not be different molecules, but these are different molecules.